Let's discuss nonlinear inequalities. So basically what we're talking about are polynomials, such as quadratic or larger, right? Cubic or anything with an exponent bigger than that, um, where we might be talking about an inequality. So such as the three that are listed here, you'll notice the one in the middle is actually graphed. What we're really asking the question of is, when is your polynomial, right? So this 2x cubed minus 2x less than or equal to 0? Now, it doesn't sound like a very tricky question, but let's consider a couple of small things here. First of all, a couple things to remember about inequalities. Number one, when we're trying to solve an inequality, if we divide by a negative number, such as here where we're trying to get rid of that -2, we're going to have to flip the sign. Remember, where with an inequality, anytime we algebraically divide or multiply by a negative number on both sides, we're going to go ahead and flip that inequality. So less than just became greater than. So we need to remember that small rule. Then the other thing, the large idea with this, or the big thought is, well, that means that we have multiple answers. X is greater than, so again, not equal to. We're going to do an open circle there. Let me redraw that so we can definitely see it's an open circle. But then every number greater than that, right, works for an answer. Now remember, when we're solving equations, as long as we do the same thing on both sides, we should be in pretty good shape. So here we're trying to get rid of something squared, so we're going to square root it. But what you got to remember is, technically we're considering the question, and I'm going to go ahead and redraw that. We're considering the question, well, when is positive x, right, squared equal to 9, or technically a negative x squared equal to 9, because we wouldn't know the difference. Negative number squared is still going to be a positive 9. So we'd have to kind of, when we take that square root, right, we take the square root of all sides. Over here, we're just going to get x equals 3. But over here, we get negative x equals 3, or basically x equals -3. Right? Well, now the tricky part, the hard part of this comes in when we combine these two ideas. Because again, dividing by that -1 over here at the right, we would need to flip the sign if that would have been an inequality. But wait a minute, we're going to have one part that doesn't get flipped. We're going to have one part that does get flipped. How do we kind of keep track of that when things get a little trickier? Such as down at the bottom here, we're going to have to split this into two parts. I'm going to have to say x squared is less than or equal to 4. Or negative x, again, squared, could have been less than or equal to 4. And I'm going to have to solve those two things separately. Now, again, that's not terribly difficult. We can definitely do that. X being less than, right, or equal to 2. Or negative x being less than or equal to 2. Therefore, x greater than or equal to -2. And again, if we think about our graph, we got from -2 to 2 then. We're going to be greater than and less than. We're going to be greater than the -2 and less than 2 all at the same time, right? Or technically we should say and here, since we're sort of in between those two things. Well, now again, that's very doable by hand, but what happens when things get a little more technical? What if our quadratic gets a little messier? Or what if we're not even quadratic? What if things get a little bit larger? How do we consider that? Well, there's a little bit different technique, and here's how that technique goes. If I want to solve a quadratic inequality, what I'm going to do is come up with some test values. So first things first, I'm going to ignore that inequality right up here, and I'm just going to consider the equation. And to solve a quadratic, again, an easy way to do that is factor. So I factored the left side. 5 times -3 was -15, and 5 plus -3 was 2. And if we solve those, we get two values, right, of -5 and +3. Well, now if I put those on a number line, right, -5 and +3, what I want to know is not where are we there, because again, at those 2 points, we're right at 0, right? We're going to be equal to 0 at -5 and at 3. But what I want to know is in between those points and beyond those points, when would I have been less than 0, right? Just like that original problem up there. When would I have been less than 0? So what I need to do is pick 3 points, coordinates to the left of, in between, and to the right of my test values here, right? My points. So I'm going to pick -6, 0, and 4, right? I've got -6 over here. I've got 0 in the middle, and I've got 4 out to the right, right? And what I want to know is, would the values to the left, right, or in between there be greater than 0 or less than 0? Because again, if we're only 0 at those points, well, we know from the intermediate value theorem that at -5, we must be crossing from negative to positive or positive to negative then, right? If we're thinking about a quadratic, right, a parabola, somewhere in here I must be crossing from top to bottom or bottom to top. Well, when we plug those values in, right, to our original function, right, if we take these x values and we plug them in up here, right, what we're going to end up finding out is that the values we get back are 9, -15, and 9, which essentially are a positive value at -6, a negative value at 0, and a positive value at 4. And because the only points we're crossing the axis are -5 and 3, well, then all of the points between -5 and 3 are going to have a negative y value, which is what we want, right? We want it to be less than 0. So therefore, I know that all of the values, right, because of this value, all those values in between here, right, from here up to here, all those values are going to have negative y values or negative output values. So therefore, in interval notation, my answer would be -5 to 3. Now, you can check your answer by graphing. If we actually graph this equation as though it was equal to y, right, I would get a graph like this over here at the right. And basically, remember, we're looking for when is our equation less than 0? Well, everywhere, here's my x-axis, everywhere down below the axis has a y value less than 0. So everywhere between, again, -5 and 3 basically is less than 0. Let's take a look at a couple other examples fairly quickly. We'll just walk through the same way. Again, if we're going to solve a quadratic, it's nice to have it be equal to 0. I'm going to ignore that inequality at first and just solve the equation. So I factored the left side. Again, 2x plus 1 and x minus 5 should be the factored version of that expanded up top there, which means my two answers, if I set them both equal to 0 and solve, are -1/2 and +5. Well, if we put those on our graph, again, I need to pick some values. So I'm going to pick -1. 0 would still be in between the values, and I'm going to go with +6. Again, plugging those three numbers back into our original equation here, right? 2x squared minus 9x minus 5, or you can plug them in the factored version. Either way, we're going to get these three values back. And remember that this time we're looking for when are we greater than or equal to 0. Well, that would be at 7 and at 13, or basically we're positive, negative, positive, and we wanted the positive values on here. Now, notice we also want to be or equal to. So we're okay with being exactly 0. So I'm actually going to include, right, my two numbers in my interval notation this time. So you'll notice we go from -∞ up to -0.5, including, note the hard bracket there, right, -0.5. I'm going to start at 5, and I'm going to go to infinity. And again, if we check our graph, the two places we were positive are on the left side, all the way up to that -0.5, and then from 5 to infinity, right? The two ends of our graph this time, we were greater than 0. Let's do one more very quickly. Again, looking at this one, don't forget we're going to factor, so I'm going to factor out a 2x. And then I'm going to factor again, x squared minus 1 would be x plus 1, x minus 1. Ignoring the inequality, we'd have three zeros, 0, 1, and -1. Again, putting those on our graph, now that means we're going to have, oops, go -1 over here, +1 there. That means that we're going to have to pick some fractions there. We need to get between -1 and 0 and between 0 and 1. So again, I'm going to pick some points. I'm going to get their y values back. But again, all I really care about is at -2, we're going to get a -12. Then I'm going to get a positive number between -1 and 0. I'm going to get a negative number between 0 and 1. And then positive values out to the right, right, at that +12 there. Positive values again. So again, we want the negative values or equal to 0. So again, negative values include the zeros again. But I want the points here and here. So our interval notation is going to look like -∞ up to -1, include the -1, and from 0 to 1, including again both 0 and 1. And again, if we check our graph, notice that's where we had negative values down to the left and in between 0 and 1. Hopefully that helps you with absolute, or sorry, not absolute value, but with polynomial inequalities, right? Solving non-linear inequalities a little bit in a different way. Again, why would you want to know this kind of thing? One idea would be, what if we're looking for the domain of a polynomial? Remember that we would want whatever's under the root. I'm not that worried about the root when it comes to domain, but I want whatever's under the root to be greater than or equal to 0. So I might have to solve something like this to help me find things like domain. If you have any questions, talk to your teacher. Otherwise, have a great day.